In section 1.9, we're going to look at the general form of the equation of a line. The general form is ax plus by equals c, as opposed to slope-intercept form, which is y equals mx plus b. We're going to write the slope-intercept form of the equation in general form, so turning it from general form into slope-intercept form. Then we're also going to talk about horizontal and vertical lines and graphing equations using intercepts. This one we've done before in previous sections, so we'll redo that for general form equations. All right, so in our first scenario here, we are going to be building a fence around a skate park, and we have enough money in our budget to purchase 350 feet of fence. The only stipulation is that the width must be between 35 and 60 feet to properly enclose the new ramp, and the length is going to depend on the width we choose. Our task is to determine the length and the width to make sure that we use all of the fencing, so we use all of their budget. Okay, so what value does the 350 represent with regard to the rectangular region? So I've got my skate park, and I'm going to be drawing a rectangular fence around it. And the 350 is going to be the outside edges of my skate park, and so it's the perimeter. And in a situation like this, if I let x be the widths and y be the lengths of this rectangular region, write an equation for the perimeter. Okay, so I know that my perimeter is going to be composed of adding up 2x's plus 2y's. So 2x plus 2y equals my perimeter, but remember my perimeter is 350. So this is a linear equation that is in general form. General form has a number of x's plus a number of y's equals a constant. So the a value here is 2. The b value here is 2. That's the number of x's, that's the number of y's, and the c value is 350. So just making a note that this is in general form. Now, general form is certainly not as useful as slope-intercept form because these values, a, b, and c, don't mean anything in terms of the graph. They just mean things in terms of the perimeter, where there are 2x's, 2y's, and a total perimeter of 350. Okay, taking a look at the next page, my goal is going to be to rewrite our equation in slope-intercept form by solving for y in terms of x. So I currently have 2x plus 2y equals 350, and I want to solve for y. So I'm going to need to move the x to the other side. So we're going to subtract 2x from both sides. I don't write small enough for this to all fit in this little box, so I'm going to move over here. If I move the 2x to the other side, it's going to be gone on this side when I subtract the 2x. I can either write this side as 350 minus 2x, or if I choose, I could put the minus 2x first, and that's what I usually choose to do. I like to keep my variable component first. Y equals mx plus b is my chosen form. So it's either 350 minus 2x or negative 2x plus 350. Again, we're still trying to get y by itself. So this y has a coefficient of 2. We're going to divide that 2 off. When we divide the 2 off, we're going to make sure that we distribute it so everything gets divided by 2. So y equals negative 2 divided by 2 is negative 1x, or just negative x. And then 350 divided by 2 is going to be, I think 175, but I'm going to check just to make sure. We take our 350 and we divide it. Oh, I thought I was typing. There we go. 350 divided by 2, we get 175. So plus 175. Okay, so this is our equation rewritten in slope-intercept form. Now that it's in slope-intercept form, we can see the slope because it is the coefficient of x. The coefficient of x right here is negative 1. And then what does this mean? What is the practical meaning? Okay, so we need to know what the output is. I gotta get my decimals part away there. Here we go. The output is increasing or decreasing by how much per input. So the output is y, and remember that y stood for the length. So the length, what is it doing? Decreases, because it's negative. Oops, decreases. I was thinking about writing the word by. I don't know why there. Decreases by 1. What are the units on this? The are feet. And then per, what are the input? The input is width, so it's per foot of width. The units on that are also feet, so per foot of width. Length decreases by 1 foot per foot of width, or per 1 foot of width. Every time the width increases by 1, the length decreases by 1. Okay. What is the vertical intercept? Well, I can see that here it must be 0, 175 from our b value. What does it mean? All right, input is width, output is length. So if width is 0 feet, the length would be 175 feet. So my fence would collapse on itself, no width, just 170 feet length, two-sided, making up the total of 350 if I go there and back again with no width between them. You can't make a fence like this, and so this is model breakdown. When nothing makes sense, or when something does not make sense, you say that the model has broken down. Model breakdown, I can certainly make the prediction, but that doesn't mean that the prediction makes sense. So I will give the prediction and state that it does not make sense with model breakdown. Practical domain and practical range. Okay, so first of all, I note that for domain input, I need to know what the smallest possible value for input, I'll write domain input, will be, and what the largest possible value of input will be. Now, I know the smallest possible value of input is going to be 0, because I certainly couldn't have a fence with a negative length. So 0. Now, I can't actually have 0 either, because the model breaks down when it is 0. So I'm not going to bracket this. We're going to parenthesize this 0, because we don't want it to be 0. We want it to be just bigger. So the parenthesis means I don't include 0 itself, but I could possibly include values that are just a little bit larger than this. Now, as I'm thinking about this, I'm going to modify this again in a second. And then I need to figure out what the largest is. One of the ways to do that quickly is to graph the original function and zoom out quite a ways to find out where the graph touches the x-axis. So values between 0 and 175 would be potentially feasible for the input. I'm going to have to modify this in a second as I remembered something else. But I'm going to put the 175 right here temporarily. And those came from the graph of this function, noting that at this point, which was 0, 175, and at this point down here, which was 175, 0, that the domain x was going to have to be between those two. Okay? Certainly going to have to be between those two. Now, if the graph was all I had to go off of, that's what I would say. However, I did remember something else. I was starting to write this down, is they actually gave me a tighter restriction in the description. It said they had a stipulation that was made by the people who made the rules about this fence, that the width had to be between 35 and 60. So they've actually told me what their a tighter practical domain would be based off of the zoning requirements or whatever in this situation. So we do have additional information beyond just the graph for this situation. So we're going to have to change this to tighten that domain down to 35, 60. All right, and I put brackets around the 35 and the 60 to signify that, yes, we can include the borders. We can include the 35 and the 60. So depending on your context, sometimes you don't have a verbal or written description to tighten your domain. Then you could use the broader domain, but here we'll tighten it down and say it's there. Okay, so now what does that mean for our range? If we have a tight domain, we're going to have the tight range based off of it. So if not, then I would have used 0 to 175. So just to keep in spirit, I'm going to write that down as the broad range, but then we're going to tighten that range down based on the 35 and the 60. Now it's not 35 and 60, however, 35 as an input value and 60 as an input value, we want to see where those match up, what the height values are for those. So 35 matches up with 140, 60 matches up with 115. So if my width is restricted to being in between 35 and 60, that means that my length has to be restricted between the outputs of 115 and 140. So that's where these values come from. I am restricted to 115 to 140. Okay. So again, big conversation about all the different ways I could have considered domain and range. For this question, I want to answer with those two that I have in green. Okay. Determine the corresponding y value for x equals 35 using the general form of the equation. Okay. So 35 for x. So 2 times 35 plus 2y equals 350. 2 times 35 is 70, plus 2y equals 350. And if we are solving for y, we're going to subtract the 70 from both sides. And that gives me 2y equals, if I take away 70, I should be at 280. And then we'll divide both sides by 2 to get our y by itself. And so y would be equal to 140. Now, we already saw this graphically, actually, because when we graphed it, we saw that the x equals 340, or sorry, the x equals 35 did correspond with the 140, and we can look at that again in the graph, right? 35, 140. So good thing our answer matched when we did it by hand. We also got 140. Hang on, they're trying to resize it. There we go. So that would be the y value that corresponded, or I could fill in and complete that ordered pair as 35, 140. All right. Part B, determine the corresponding y value for x equals 35 using slope-intercept form of the line. So I already solved for the slope-intercept version of the line up here. Now we're going to plug in the x equals 35 there instead. So y equals negative x, negative 35, plus 175. So that gives me y equals 140. So again, 35, 140. All right. So was it more convenient to use the slope-intercept form or the standard form to do this? It took a lot more work to use standard form than it did to use slope-intercept form. So I would say slope-intercept form was more convenient. So less work, more convenient to use the slope-intercept form there. All right, complete the table to determine some possible lengths and widths for the rectangular region. So we're going to use decimals to assist us in this table because we can. So I'm going to type in our function. I do have to be in function notation to do this, to do an autofill table. So the original general form is not going to be good enough. So I do need to enter my function, f of x equals negative x plus 175. We had that y equals negative x plus 175, writing in function notation. So I can do my table, and I can make it autofill with f of x1. And then I can plug in the 35, the 40, the 50, and the 60. Okay. So one of the additional advantages of slope-intercept form is that I can use autofill tables here. I'm going to fill these in. We have 140, 135, 125 and 115. Okay. Oh, interesting. So the next question is use function notation to write the length as a function of width. And that's what we just did. F of x equals negative x plus 175. Had I not been using decimals for my calculator, that would have not been necessary prior to the table. It's technically not necessary prior, but it does make it more convenient. So we do those in tandem. We write it in function notation in order to get our autofill table to compute. If I wasn't going to use an autofill table, I could have done it by hand. It just would have taken me more time. Okay, that finishes the example about skateboarding for now. We're moving on to something new in number 5. We are working in a purchasing department. We are going to buy some VR headsets and some tablets. Okay, we have a budget of $12,000, and we know that the average wholesale cost of the VR headset is $125 each, and the tablet costs $400 each. All right. All right. If G represents the number of VR headsets that I can purchase, write an expression for the total amount I can spend on VR headsets. Okay, so if I'm going to buy G number of VR headsets, each one of them costs $125. So their total cost would be 125 times G. And if each of the tablets, we're going to call those C, I don't know why C, but if each of the tablets costs $400, then the total amount that I would spend on tablets would be 400C. We're building this equation up slowly. We're going to put those two pieces together on the next page. Now, the full linear equation. Remember, we had a budget of $12,000. Our VR headsets were 125G, and we're going to add in some tablets at $400 each, and the total of however many headsets and however many tablets has to reach that budget level of $12,000. Solve my equation for C. So I have to write it over to the side because I know I'm not going to have room in that little bitty space there. So I'm just going to start over here to begin with. Okay, I want C by itself. So I got to move the G thing over. So we're going to subtract 125G from both sides. Then I have 400C equals 12,000 minus 125G, or I like my variable first, negative 125G plus 12,000. Then we're going to divide by 400 on both sides, making sure to distribute this. So I'll have my C equals, I've got negative 125 divided by 400. Let's go ahead and express that as a decimal. We're going to have negative 125 divided by 400. If we were in a non-contextual situation, we'd go for the reduced fraction, but in the context of this one, decimals make the most sense. So negative 0.3125 G plus, I know you can't see what I'm writing, but I'll get back to that in a second. I want to also do the division of 12,000 by 400, which is 30. So plus 30. All right. So our equation is C equals negative 0.3125G plus 30. Now, I wrote the whole value right here. It's only 4 places. Sometimes we'll round it down to 1 or 2 places, but with only 4, there's no problem keeping the entire value unless we're specifically told to round it to fewer places. So if I round it to 3 places, I have to round that up to 0.313. 4 is just fine. Okay. What's the horizontal intercept of this function? Well, I can see it right here at 0, 30. Oh, I am mistaken. It said horizontal intercept. I did the vertical intercept. Oh my goodness. Good thing we noticed that before we got too far into that question. That's the horizontal intercept. I don't know that one right now. I know the vertical intercept, so I'm going to come back and do that one first. Okay, vertical intercept, that is So for zero is independent. That's G. G was VR headsets. Dependent, C is tablets. So if you buy zero VR headsets, you can buy 30 tablets. All right. How am I going to find the horizontal intercept? There's two ways. I could do it by hand. If I was going to do it by hand, I would actually put 0 in for the dependent variable, and I could do it in either this part or here in the original. It's easier to do it in the original in this case. So if I put 0 in for the C, I've got 125G plus 0 equals the 12,000. And so I know I can just divide off the 125 to get G by itself. So if I compute whatever 12,000 divided by 125 is, I'm going to get the horizontal intercept at 96. So this would be 96, 0. And this means that if you buy 96, independent is the VR headsets. You can buy 0 tablets. All right, now I want to talk about those two graphically instead of algebraically. So back over to my decimals graph. I already had this function graphed, so I could have just taken a look at the intercepts here. I do not have this function graphed. This is the previous function. I better graph it real quick. So I had C equals negative 0.3125 G plus 30 and resize. There we go. Now I can see there's my 96, 0, and there is my 0, 30. So I can see both my vertical and horizontal intercepts graphically. You absolutely can find them graphically. I was just trying to also show how it could be found algebraically. What is the slope of this function? Well, I found it up here when I solved for C. The slope is negative 0.3125. What does this mean? What's the significance? Okay, so the output, which is the number of, C is tablets, the number of tablets you can buy decreases, because it's negative, by 0.3125 tablet, as would be the units, per VR headset purchased. That's the independent variable. So each time you make one more VR headset purchase, you can purchase 3.125 less tablets. Almost a third less tablets. Okay, a third of a tablet less, I mean to say. Practical domain, practical range. Okay, I'm going to check our situation again. I don't believe that they gave us any criteria for the minimum number of each one to buy, and I do not see that in number 5. So we are going to use our intercepts to help us with the domain and the range. Hopefully it's clear that the fewest number of domain is G is VR headsets. The fewest number of headsets you could buy is 0. It didn't say you had to buy any, so you could actually buy 0, so we're going to bracket it. And then the most that you'd be able to buy was if you bought 96 of them and you didn't buy any tablets, so 0 to 96. And then for the range, again, for tablets, the fewest you could buy is 0. The most you could buy would be 30, because if you bought more than 30, you're going to go into a negative number of VR headsets. So again, you can see that graphically as well. with those 2 points, if you go on the domain, if you go bigger than 96 in the domain, the outputs would become negative and you would not have something that made sense in this context. And if you went higher in the range than 30, again, the inputs would become negative, so it's not going to work. So inputs between 0 and 96, outputs between 0 and 30. Okay. Equations of a horizontal line. All right, so we're back to our skateboarding ramp here. When the ramp is complete, you and your friends will be able to pay a monthly fee of $12.50 to use the ramp for as many hours as we wish. Complete the table of values for X the number of hours per month that you use the ramp. So I use it for 0 hours. I'm still paying my $12.50. I use it for 5 hours. I gotta pay $12.50. I use it for 10 hours. It costs $12.50. Doesn't matter. It costs $12.50. Doesn't matter how much I use it. It just costs $12.50 to get the monthly subscription. Okay, data point to sketch the table. So let's say that's where 1250 is as a height. Up, I just put it arbitrarily. I'm not going to scale this thing up. All the outputs are 1250. And then let's say that this is 0, 5, 10, 15, 20, and so on. We have 0, 1250, 5, 1250, 10, 1250. So this is going to graph as a horizontal line. There's only one output, no matter what the input is. Describe the graph in words. This is horizontal through a height of 1250. Or 12.5. Choose 2 ordered pairs and find the slope. Okay, so how about I pick 0, 12.5, and why not the next one, 5, 12.5. All right, so for the slope ratio is the change in output, so 12.5 minus 12.5 over change in input, 5 minus 0. That gives us 0 across the top, 5 across the bottom. 0 divided by 5 is 5. What is the practical meaning? There is 0 change or no change. I'll have to write that over here. There is no change in the output, which is cost. And this no change is because it's 0 change. 0 change is no change. No change or 0 change in the cost. Okay. What are the intercepts, vertical and horizontal, of if they exist? Okay, so the vertical intercept, remember our line looks like this. The vertical intercept was 0, 12.5. Horizontal intercept, where I touch the horizontal axis, I don't. There is none. Write the equation of this line in slope-intercept form. All right, so y equals m. The slope is 0. X plus the vertical intercept, which is 12.5. Or you don't need to write 0x. You just write y equals 12.5 because 0 times x is 0. So y equals 12.5. Anytime we're going to have a horizontal line, the equation is going to be y equals c, whatever c is the constant, where that's your height. That's your height. It's your vertical intercept. It's all your heights, actually. So it's always y equals some number. F of x equals that number if you're writing in function notation. And also noting the slope of any horizontal line is 0, as we saw above. All right. So continuing on here, we have determined 3 ordered pairs that satisfy each of the equations, then sketch them all on the same coordinate axis. All right, y equals -2. So that's the y value. That's always the y value. I'm going to draw in x and y axes here because it wasn't too specific about where it wanted me to start on this one. And I'm just going to say -2 is the height of this one. Let me use a different color than the axes. And so this graph is horizontal through -2. That's what it looks like. And so it's got lots of points. It's got 0, -2. It's got 1, -2. It's got 4, -2. It doesn't matter what I pick for x, right? I'm just picking random stuff for x because it's got all of these points. It's got -4, -2. It's got all of these points that have -2 as their output coordinate. All right, so another one, we would graph f of x equals 1. Okay, so it's in function notation. So it's got 1 as its height. And so I could say 1, 1. I could say -5, 1. I'm just picking random stuff, right? Random stuff for the input. The output is 1, and I could have 0, 1. And the last one we need here is 5 halves. One, it may be helpful to think about 5 halves in decimal form, 5 halves as 2.5. So up 2.5. And again, I can pick anything I want. I can pick 0, 5 halves. I can pick 1/3 5 halves. Got fractions in there. Why not add a fraction for x? I can choose anything for x as long as the output is 5 halves. So -7/9, 5 halves. We're just being frisky there with some input values. All right. Next, equations of vertical lines. Okay, so in the situation down here at the bottom, we are applying for a part-time job at the skating rink to help cover weekly expenses. We got our salary and we have our weekly expenses. So my salary is $70, but the first week it cost me $45 to buy groceries. My salary is still $70, but now my weekly expenses are $35. My salary is still $70, my weekly expenses are $50. My salary is still $70, my weekly expenses are $60. My salary is not changing, even if my weekly expenses change. All right, so next page, sketch a graph of this. Okay. I need to look at my numbers. I got 70 as my expenses. So let's count by 10. So 10, 20, 30, 40, 50, 60, 70 for my expenses. That's the independent variable. And I am extremely sorry. That's my salary. I have to look back at my context before I talk sometimes. That's my salary. My expenses are dependent. Okay. So my salary was 70. I wish these were on the same page. And then I need 35 up through 60. So let's just go by tens again. So 10, 20, 30, 40, 50, 60. I need 70, 35. I need 70, 45. I need 70, 50. And I need 70, 60. So if I connect these, you can see that this point is going to form a vertical line. So we can say that our graph is a vertical line through x equals 70. Choose two ordered pairs and determine the slope. Okay. I'm going to pick 70, 50 and 70, 60. Just said pick any two, so those are the two I pick. Output over input. Change in output. 60 minus 50 over 70 minus 70. This is 10 divided by 0, and I can't do 10 divided by 0. It is undefined. It doesn't exist. You can attempt to do this in Desmos. It's going to give you some kind of message. Let's find out what the message says. If I calculate 10 divided by 0, yeah, undefined. Like I said, undefined is the error message that it gives you. It's not possible to divide 10 things into 0 piles and have an equal number of things in each pile because there are 10 things. They've got to go somewhere. They can't go in 0 piles. They have to be somewhere. So not possible to do this division. What are the intercepts, vertical and horizontal? Well, there is a horizontal intercept down here at 70, 0. That's my horizontal intercept. And for vertical, there is none. because it's not going to cross the vertical axis. Okay, next, is this a function? No. It doesn't pass the vertical line test because there are multiple outputs for a single input. So the input 70 has multiple outputs, or it doesn't pass the vertical line test, would be the graphical way of explaining it. Do the ordered pairs in the table satisfy the equation x equals 70? Yes, they do, because the x value for each of them is 70. The y value can be whatever you want, but the x value is 70. All right, can you graph the equation using your graphing calculator? Ho, ho, ho. Okay, so this is a question where if you're using one of those old handheld TIs, the answer is actually no. But if you're using Desmos, the answer is yes, because Desmos is awesome. And you can graph even vertical lines in Desmos. So yes, because Desmos will allow us to graph things that are not functions. That was not possible on the old TI calculators, so they probably would have said no. We're going to say yes because Desmos is awesome. That's what I'm going to write. Yes, on Desmos. Okay. Summary down here, vertical lines are always of the form x equals a number. Our horizontal lines are always of the form y equals a number. If it's going to be a vertical, x is the thing that is fixed. X is some fixed number. The slope of a vertical line is undefined. There is not a slope. It's not zero. It's just undefined. There is not a slope. And last, we have the similar activity that we did before. Draw some vertical lines through a couple different areas. So let me get my graph. I'm going to draw x and y axes in the middle here. And then we want to sketch x equals -2. All right, so x equals -2. It's going to go straight up and down over here. Doesn't matter what y is, but the x value is always -2. So -2, 0, or -2, 1, or -2, -2. Doesn't matter what the y coordinate is, the x values are always -2. So -2, 0, -2, 1, -2, -2 are all points in the line, just to pick 3. Okay, x equals 4. Okay, so 1, 2, 3, 4. All right, and 3 ordered pairs. Let's do 4, 0, 4, 1, 4, -3. Again, random numbers for y. Doesn't matter what y is as long as your x is 4. And lastly, 5 halves. So again, that's our 2.5. And that would be right here. And so we have our 5 halves, comma, 5. And 5 halves, comma, 4/9. And I'm picking random stuff. I just grabbed a couple fractions for fun. 5 halves, comma, -1/12. All points on this line. Because their x coordinate is 5 halves, the y coordinate could be absolutely any and every number that you would choose to put in there.